All right, welcome back. We're going to finish up topic 8.6. This topic, again, we have covered so far how to predict the products, balance the equation, and determine the solubility of a double replacement reaction. We're going to continue working towards what's called a net ionic equation, which builds off of what we've accomplished so far. So what we're going to do is take an example we've already worked out, and that was this very first one between the lead nitrate and the potassium iodide. This is what we're going to use as our guided example to then show you how you go towards a net ionic equation. Because basically a net ionic equation boils down to what are the most important parts to get to the point of what made that precipitate. So what we're going to do real quick is just translate what we already have. So we said we had Pb, NO3 aqueous, reacting with potassium iodide, and we had two of them, coefficient of 2, forming the lead iodide solid and a coefficient of 2, KNO3, and aqueous. So again, nothing new has been added here. It's exactly what we finished up with the first guided example in the notes. All right, so we have already accomplished then number 1, and we've already accomplished number 2 in the 5 steps to getting towards the net ionic equation. So we've kind of covered some of the steps. Now we're going to add a few things on. Again, how do we get to the most important part that gives you your ions involved in making the precipitate? So what we need to do is we need to write what's called a total ionic equation. So essentially what you're going to do is you're going to take this equation here, and we are going to separate it into its ions. So what we have is, to start out, the very first thing that we have is the Pb. And we already established that Pb was a +2 as we worked through that example. So we're going to say Pb +2 aqueous is combining with, okay, and now we need to account for how many we have. So we only had one Pb ion. Here we have 2 NO3 ions. So we're going to put +2 NO3 -1, and it is aqueous. So that aqueous applies to both the cation and anion. And again, you want to account for your inventory, how many you have. As we move on to our second reactant, we have a coefficient of 2 here. So that means I have 2 potassium ions that are aqueous, and I have 2 iodine ions that are also aqueous. So what this tells me is that I've taken these two materials, I've made them into aqueous solutions by dissolving them into water, and essentially I have a free-for-all in these different ions in that solution. When they combine, what forms? So when you get to the product side, you never break up your precipitate because it is no longer in ionic form. Again, as soon as it's a solid, they have bonded together and they have settled out as a solid. So when I get to this point, I'm going to keep the Pb I2S together. You only break apart things that are aqueous because that means that it is in an ion form. Following with my last product is aqueous, and I have a coefficient of 2. So I have 2 K+1s and 2 NO3s with a -1. I will tell you, net ionics, it takes a lot to get through to them, and total ionics just is a lot of, again, it's not hard work, I don't think. There's just a lot of steps to it. So the idea is we're looking at what ions are involved in making this solid precipitate. So the next thing we're looking for, and we're going to kind of do number 4 in this step here, is we are going to cancel out any spectator ions. So you've maybe heard the word spectator. If you're a spectator at a sport, you're not participating in playing the basketball game, you're observing the basketball game. So spectator ions are what you find on both the reactant side and product side. These are the ions that are not involved in making the precipitate. So what was not used for this? You should see them on both sides. So I start here. one of the spectator ions that had nothing to do with making the PbI2 was the 2K plus 1. That should balance out with the reactant side. Notice I have 2K plus 1. So I'm going to put a slash through those, indicating those had nothing to do with making this. My other spectator ion is this 2 NO3s, which I have here, 2 NO3s. So what I'm left with, because these are going to be left over floating around in that solution, they had absolutely nothing to do with forming this precipitate. Now I can write a net ionic equation. So I'm going to get this out of my way. I'm going to keep this on the screen for now. And so from here, we now have our net ionic equation. We had Pb plus 2 aqueous. It reacted with 2 iodine ions. It resulted in the formation of PbI2s. The one thing you get when you get to your net ionic equation is it's already balanced out by all the work that you've done ahead, and this is a net ionic equation. So we have 2 more that we're going to look at. Again, we're going to use the examples that we've already done from up above just to save some time and give you more time to work on your homework. Okay, so this one was the AgNO3 and the NaCl. Going back to our note page, we said it made NaNO3 aqueous, and it made AgCl solid. So this is the molecular equation. Let me write that in a different color. And it's already balanced. So our next step is we need to write the total ionic equation. So this is involving all the reactants, all the products. We're going to break them apart into their ions. The thing that's nice about this particular equation is it's already balanced. So we have Ag plus 1 aqueous plus NO3 minus 1 aqueous. Separating my next reactant, I have sodium, I have chlorine, plus 1, minus 1, both of which are aqueous. Okay. Again, in this particular problem, I will not have coefficients because, again, I don't have any of my polyatomics in parentheses, there's no other subscripts, and there's no coefficients. That's why this particular example does not. Going to the product side, my first reactant here is aqueous. It is not the precipitate, therefore I will separate it. So we have Na plus 1, NO3 minus 1. However, my last product here is the precipitate. Therefore, I will keep that together. It is not an ion, and we're done. Again, this is the, let's see, I called it the total. Yep. Sometimes they're called complete too. So total ionic equation. Okay, now we're at the step that we need to start eliminating. Again, what we are going to eliminate are the spectator ions, the ones that had nothing to do with this AgCl. You'll see them on the product side. They should also be on the reactant side. So I see the Na here and the Na here. That's spectator ion number 1. NO3, NO3. This is my second spectator ion. So whatever is remaining, which is the Ag, the Cl, and my precipitate is what carries forward into the net ionic equation. So my net ionic equation is Ag plus 1 aqueous. Those are going to come in contact with chlorine ions. When they come in contact, they're going to bond. They're going to make this precipitate and settle out. Again, this is the net ionic. And we're done with example 1. The last one has a slightly different spin on it because that one is the one that involved the formation of water. Looking at how we wrote the example when we did the reaction originally, we said that we had H2O liquid. I said you could also write it out as HOH. and we had LiCl. So this is the molecular equation. Okay. Again, this one was already balanced on its own, which was nice. And so we can start working through our steps, breaking apart everything into our total ionic. We have hydrogen, chlorine, lithium, hydroxide. All of the reactants are aqueous. Hydrogen's a +1, -1, +1, -1. Again, we had all that information already from up above. Okay, when you get to the product side, you don't split apart two things, anything or three things really. Gas, I really don't have you guys do any with gas at this point. If you go on to AP, you'll see that there. I tend to do the liquids and the precipitates. And so you do not separate anything that's in the liquid phase or anything that's in the solid phase. Only things that are aqueous as ions you break apart. So the H2O is going to stay together, and lithium and chlorine are still aqueous on the product side. We're going to break those apart. And we now have our total ionic. So again, your next goal is you have to identify any spectators. Again, if you look on the product side, you should see those on the reactant side. So lithium is left over as an ion, chlorine is left over as an ion. So what was involved in forming and allowing a reaction to take place? With this particular example, we have hydrogen with a +1 aqueous combining with hydroxide -1 aqueous. It resulted in the formation of water. Therefore, the reaction took place. This is my net ionic, and we are now done. If you have any questions about net ionic, again, identify any questions through email or save those for a Google Meet, and I will gladly address any points of concern.